Bismillahirrahmanirrahim. Calculus 1 Introduction. This course mentally for students of mathematics, College of Science, Al-Majma'a University. Before going through calculus, I have to make some short introduction. Calculus, which is sometimes called the mathematics of a change, is the branch of mathematics concerned with describing the precise way in which changes in one variable relate to change in the another one. In almost every human activity, we encounter two types of variables: those that we can control directly and those that we cannot. Fortunately, those variables that we cannot directly control, we often respond to some way to those that we can control directly. Plenty of students ask me about the benefits of calculus, why we study calculus. Mathematics is not theoretical science that's separated from real life problems. Mathematics is applicable science, and indeed calculus is one of these branches. Now I will introduce the most applicable or applications for calculus 1 in the real life problems. For example, FBI fingerprint comparison. The US Federal Bureau investigation began controlling the fingerprints and handprints by using calculus. Also in music, in the field of music, researchers with the numerical algorithms research group in Yale University have investigated the application of wavelets to sound. By using some calculus functions, they could separate the noisy from the functions and make the sound high definition by removing the noise from the data in the field of engineering. Also, calculus applied to the airflow passed in an automobile. For the designing of new cars, we have to study fluid flow such as air, water, and blood. In this field, calculus takes a hand. In weather prediction, scientists use calculus to make accurate weather prediction, which is a very big problem in real life, daily life. Also, calculus takes a hand in medical image and DNA structure, in controlling chaotic behavior in the human heart. The first and the most important definition in calculus, which we call functions, الدوال. As you see this image of the very famous scientist René Descartes, who deal with these issues. Now, before calculus, I have to define what we mean by function or image. A function is a transformation from two non-empty sets A and B. We call it function if for each x element in A there exists one and only one y element in B, such that f of x equals to y. Let us take this example. The set A contains elements x, y, and z. X have image which is alpha, y has image which is alpha also, z has image which is beta. We can call this function. Why? Because each element in A has one and only one image in B. Although we have two elements in A have the same image in B, this is not a problem with us. we restrict ourselves to the definition. If we take this example, x contains 1, 2 and 3, y contains 5, 6 and 7. We have here the image of 1 equals 5, the image of 2 equals 7, while 3 has no image. For this reason, this is not a function, because since there exists 3 elements in x, but there exists no image of 3. If this condition is satisfied, we call A the set of independent elements, which is the domain of the function. We name B the set of dependent elements, which is named the codomain of the function. Another example, take A, the elements of A, alpha, beta and gamma. The elements of B will be A, B and C. The image of alpha will be A, the image of beta will be B, and the image of gamma will be C. This is a typical example of a function. The domain of the function A will be the set of alpha, beta and gamma. The codomain of the function B will be the set of A, B and C. Also, the set of true images, which we call the range of B. By another example, let G be the function that transfers elements from x into y. The elements of A, 1, 2 and 3, the elements of x, 1, 2 and 3, the elements of y, 8, 9 and 4. The image of 1 equals 4, the image of 2 equals 4, and also the image of 3 equals 4. It is a typical example of function because for each element in x there exists one and only one image in y. Although there is elements in the codomain which are not an image of the x, it is not a problem to us. It is a function and we call it a constant function. The range will be 4. Another example, let H be mapping or transformation that transform elements of Z into elements of B. Z contains 7, 8 and 9, B contains 11, 21 and 23. The image of 7 is 11, the image of 8 is 21 and 23, the image of 9 has no image. This is not a function because of two reasons. For example, first, we have 9 element of Z which has no image in B. Also we have 8 which has 2 images in B, which contradicts our definition that for every x element in Z there exists only one image in B. Also this function y, we cannot call it function until this moment, but it transfers element from alpha to beta. The elements of alpha A, B and C, the elements of beta D, E and F. For each element in alpha there exists one and only one image in beta, so y we can call it typical example of functions. From tables we can describe function as follows. A functional relation y equal f of x for which x and y, the image of x is the elements of x is 0, 1, 2 and 3, the images is 3, 4, negative 1 and 6. For each element in x there exists one and only one image in y, which we call it a function. So the image of 0 will be 3, the image of 1 will be 4, the image of 2 will be negative 1, also the image of 3 will be 6. This is a typical example of a function. Note, from the equation of x equal y equals 3x squared minus 4x plus 2 is a function that has the form y equal f of x, because as we consider any element of x we can find one and only one image in y by substitution. Another example, x squared plus y squared equal a squared, we can separate it like this. Y squared equal a squared minus x squared, because x squared equal a squared minus y squared, so y equal plus or minus a squared minus x squared. If we take plus, it will be function. If we take minus, it will be function. If we take both, it will not be a function. Also, if we separate x, it will not be a function. How could we determine a function or not? We will take it further on. The general form of the circle equation to be able to solve some sort of problems is x squared plus y squared equal a squared, which is a circle symmetric about the origin with radius a. If we take an example, x minus 2 to the power 2 plus y plus 3 to the power 2 equals 16, it is an example of circle. Its center will be 2 and negative 3 with radius 4 centimeter. The graph of the equation x squared plus y squared equal 25. We can put x and get the corresponding values of y. Then we can write it like that. Now we will have different types of equations, which we have to determine which of them will be function and which is not, by which we call the vertical line test. What is the vertical line test? First of all, graph the equation of the function, or you think it is a function that you have. Graph the equation. After graphing the equation, take a vertical line from any arbitrary position you choose. If this line intersects with the curve in only one point, then the curve represents a function. If this line intersects with the curve in more than one point, so this curve represents a relation but not a function. For example, this circle equation, we take a vertical line which cuts the circumference as 2 points, so this equation does not represent a function. It is only an equation which represents a relation. For this function, take any arbitrary vertical lines. Any arbitrary vertical line intersects with graph in only one point, so this graph represents the graph of a function. This one is not a function because, as we see, the vertical line intersects with the graph in more than one point. This graph represents a function because the vertical line test any vertical line, any arbitrary, any choosing vertical line intersects with the graph curve in only one point. Now we will explain a very famous function which is called the absolute valid function. The absolute valid function has a certain definition. F of x equal absolute value of x, which gives me x if x greater than or equal 0, negative x if x less than 0, which has the following properties. Absolute value of x should be greater than or equal 0. For example, absolute value of 5 will give me 5. Absolute value negative 4 over 7 will be negative 4 over 7, because x less than 0, we have to multiply it by negative, so it will be 4 over 7. Absolute valid function has the graph like this, two branches symmetric about the y-axis. The range of the absolute valid function from 0 up to infinity. We don't have negative value for the absolute valid function. The properties of absolute valid function is as follows. Absolute value a equal absolute value negative a equals a. Absolute value a time b equals absolute value a time absolute value b. Absolute value a over b equals absolute value a over absolute value b, with the condition that absolute value b not equal to 0. Absolute value b not equal to 0, because we cannot divide by 0. We have a very famous property which is called the triangle inequality. Absolute value a plus b less than or equal absolute value a plus absolute value b. For example, absolute value 3 times 7 will be absolute value 3 times absolute value 7 will be 21. Absolute value 3 times negative 7 will be absolute value 3 multiplied by absolute value negative 7, which will be absolute value 3 multiplied by 7, which will be also 21. Absolute value 3 plus 7 will be absolute value 3 plus absolute value 7, which will be 10. But absolute value 3 plus absolute value negative 7 will be absolute value 3 plus absolute value negative 7, which is 3 plus 7, which is 10, which will be greater than the absolute value of negative 4, which will be 4. For this, we have to say absolute value A plus B should be less than or equal absolute value A plus absolute value B. Now we will take some kinds of function polynomials and determine the domain and the range for each one. For example, f of x equal x cubed, any polynomial function which does not have a denominator except 1, or not in a square root, for example, any polynomial function has a domain from negative infinity up to infinity, which we call all the real numbers. For example, f of x equal constant, its domain equal r. F of x equal ax plus b, which is a straight line equation, the domain will be r. F of x equal ax squared plus bx plus c, which is the parabola equation, the domain will be r. F of x will be ax to the power n plus n ax to the power n minus 1 until the constant, their domain will be r. Number 2, to determine the domain of the fraction function, we have to find the domain of the numerator and the domain of the denominator and find their intersection, except those points which makes the denominator 0. So the domain of the function h will be as follows: the domain of f intersects the domain of g minus the zeros of the denominator g. Now we will face some functions which we call trigonometric function. Trigonometric function is a ratios, such ratios of a right angle triangle. If for any angle which you call it x in a right angle triangle, the opposite to the function x to the angle x will called the opposite, the neighbor, the adjacent to the angle x, we will call it the adjacent, and the side which opposite to the right angle, which we call the hypotenuse. Any ratio in the world is a comparison between two quantities that have no unit. We can say A to B kilogram or meter, for example, in the simplest form and of the same unit. We can't compare between Saudi Riyal and dollar. The currency should be either in Saudi Riyal or in dollar to be able to make the ratio. Also, we cannot say 50 to 500 because it is not in the simplest form. We have to simplify it and write it 1 to 10. So A to B, it means A over B. The trigonometric function is kind of ratio. For example, sine x will be the opposite over the hypotenuse. Cosine x will be adjacent over the hypotenuse. The ratio between the adjacent and the hypotenuse. Tan x, which will be the ratio between the opposite and the adjacent. We can also find the ratio which we call cosec x, which is the ratio between the hypotenuse to the opposite, sec x, which will be the ratio between the hypotenuse to its adjacent for any angle, and cotan x, cotan this angle, will be the ratio of the adjacent to the opposite. So we can say that tan x equals sine x over cosine x, because it is A over C, A over B, which will be A over C multiplied by C over B. Now we have to take some examples from page 7 from the textbook which we study from Anton. Find the natural domain of the function f of x equal x cube. This is question number A. Question number B finds the natural domain of the function f of x will be 1 over x minus 1 multiplied by x minus 3. Find the natural domain of f of x which is equal to tan x. The first question finds the natural domain of f of x which equals the square root of x squared minus 5x plus 6. Solution of the first question. As f of x is a polynomial function, we can say that the domain of the function R, which is from negative infinity up to infinity. For the function B, it is a fraction function as we discussed before. We should find the domain of the numerator, which will be R, the domain of the denominator, which will be polynomial, also R. Their intersect will be R. Now we have to find the zeros of the denominator to make an exception. So the domain of the function f will be R minus the zeros of the denominator, which will be 1 and 3. Because if we substitute by 1, it will be 1 minus 1, which will be 0, and any number over 0 has no meaning. Also, if we substitute by 3, will be 1 over 3 minus 3 equals 0, which has no meaning. So the domain of the function f will be R, which is the common domain of the numerator and denominator, minus the set which contains 1 and 3. This set makes the denominator equal to 0. If you go to question number 3, C, f of x equal 10x, the domain will be R minus plus or minus pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and etc. Because as we see, tan x, as I discussed before, equals sine x over cosine x. When cosine x will be at the denominator, what is the values of x which makes the denominator equal 0? 90 and 270, and the periodicity, which will be plus or minus pi على 2, pi over 2, 3 pi over 2, 5 pi over 2, and etc. For the function f of x equals the square root of x squared minus 5x plus 6, we have to return back to the definition of root. Square root, what is the meaning of square root? Square root is the number which multiplied by itself give me what is inside this root. So we don't have any number which multiplied by itself give us negative value. So the value of x squared minus 5x plus 6 should be greater than or equal to 0. This is a second degree inequality which we studied in the preparatory year, which is solved by the number line as follows. First of all, factorize this quadratic formula by scissor. The last term will be positive. We have to find two numbers when multiplied by themselves give me us 6. X squared, x multiply x. By the two branches of the scissor, 3x plus 2x plus, because the last term is positive, should give us the middle term, which is 5, 6. So we take them horizontally like this, x3, x2, and the middle sign will go to the two brackets. That's good. This inequality greater than or equal 0, we have to make the whole number line and take these hedges. X minus 2 equals 0, x will be equal to, x minus 3 equals 0, x will be equal to 3. 2 and 3 bisect the whole number line into 3 intervals. One interval from negative infinity up to 2, another interval from 2 up to 3, the third interval from 3 up to infinity. Now we will take an arbitrary number at this interval. For example, we will take 1. You can take 0. You can take any arbitrary number from negative infinity up to 2. Verify the inequality. 1 minus 3 will give us negative. 1 minus 2 will give us negative. Negative multiply negative will be positive. Any positive number really should be greater than or equal 0. So this interval, any number at that interval, verify our inequality. Also, we will take an arbitrary number at that interval, for example 2.5, verifying the inequality. It will be give me negative multiply positive, which is negative. We don't have any negative number greater than 0, so any number from the interval 2 up to 3 will not satisfy our inequality. Take an arbitrary number in the third interval, for example 4, will give me positive multiply positive will be positive, which is greater than 0. So the solution set, or the interval of the solution, will be the domain of the function from negative infinity up to 2, union from 2 up to infinity, which is the domain of the square root function. Now we have to find the domain of the very famous questions like that. Tan x, as we said before, sine over cosine, numerator over denominator. So the domain of the numerator, which will be r, the domain of the denominator, which is be r, neglecting the zeros of the numerator, which will be plus or minus n pi over 2 and 3 n pi over 2. As we discussed before, all the trigonometric function is just ratios of some sides of a right-angled triangle. I noticed that some students have some sort of confusion with numbers. We have the scientists classify the number into three main third categories. First of all, the finite numbers like 5, 7, 3, 0, negative 2. Undefinite number which is not has a definite definition, like any number divided 0, which has no meaning, or the undefined. We also have a set of unspecified quantities. These quantities like infinity over infinity, 0 over 0, 1 to the power infinity, 0 to the power 0. These quantities, the scientists know that it has a very definite values, very accurate values, but we don't have the science, the knowledge to know these values, so we name it unspecified values. One of the students asked me, what about infinity? What is the meaning of infinity? Infinity has a very sharp definition. It is the greatest or largest positive number in the whole world, such that for every x, whatever big, x should be less than infinity. So we have two conclusions. We cannot reach infinity. For this reason, infinity is a not real number. Same picture for negative infinity, is the smallest number in the world, such that for every x, whatever small, x should be greater than negative infinity. So we had two very main conclusions. First, negative infinity is not a real number, and we cannot reach negative infinity. By interval, we classify open interval, a and b not with us, but the whole element between them are with us, written x greater than a and less than b, and written two open brackets like this. Closed interval, it means a and b like this with these closed brackets. It means a with me and b with me, and the whole numbers between them are with us. X greater than a or equal a, and x less than or equal to b. Should x squared minus 5x plus 6 greater than or equal 5, as we discussed before, x minus 2, x minus 3, as we make this factorize and solve in some sort of two inequalities or on the number line to get the domain of the function. Now let us go to further examples. For example, let f of x be 1 plus root x minus 2, and g of x will be x minus 3. Find the domain and formulate formulas for each of the following functions: f plus g, f minus g, f multiply g, and f divided g, and 7f. Solution. Now we are able to make some operation on functions. As we know the definition and its properties, we can make some algebraic operation on function. First of all, f of x equal 1 plus root x minus 2, the domain should be, the domain of 1 will be R, the domain of the root, the whole formula inside the root should be greater than or equal 0, so x should be greater than or equal to 2. So the domain of the function f will be from 2 up to infinity, closed 2 and open infinity. The domain of gx equal x minus 3, as it is a polynomial, will be R. So the common domain of the two function will be from 2 up to infinity. Now we can go a step further and add them. F plus g will be 1 plus root x minus 2 plus x minus 3. 1 minus 3 will be negative 2 plus x plus root x minus 2. F minus g, we can subtract the two function, will be 1 plus root x minus 2 minus, will change of the whole signs of the bracket, will be negative x plus 3. When we add the two functions, the result will be 4 minus x plus root x minus 2. As we can multiply the two functions, either 1 plus root x minus 2 will be multiplied x minus 3. We can expand and multiply. Also, we can divide f over g with the condition that g, the denominator, shouldn't be equal to 0. For this reason, x will be any value except 3. Now we can multiply 7 by any function. 7 multiply f will be 7 multiplied by 1 plus root x minus 2 will be 7 plus 7 root x minus 2. Domain of f plus or minus g will be domain fg will be domain f intersection domain g, which will be from 2 closed up to infinity opened, as we discussed before. The domain of f divided g will be domain f intersected domain g minus the zeros of the denominator, which will be g. It will be from 2 up to infinity except x equals 3, so it will be from 2 up to 3 open, union from 3 open and up to infinity. This will be fair enough for this lecture. I hope to meet you in the next lecture. Thank you.